I'm going to get going because there's a lot of content. I tend to pack these two sessions with a lot of content. So I have two here, part one, part two, and this is going to cover the fundamentals. Part two covers a little bit more, goes into design, and I have some cool demos, third-party services. And that's part two, we have Palo Alto, F5, doing GSLB, a lot of cool stuff to show you today. So let me just get started by introducing myself. For those of you who don't know, my name is Amir Ahmed. I'm a senior technical product manager within the network security and business unit at VMware, and I really focus on a lot of these multi-site and disaster recovery solutions. Okay, now this session is an advanced technical session similar to part two. So the assumption is you do have some knowledge of NSX, just because there's so much content. I tend to take these a little bit more technical than trying to cover some of the basic stuff where there's a lot of other VMworld sessions there you can attend for that information. So there's a lot of content. I want you guys to feel free to ask questions along the way. If we're running short on time, I'll let you know. And then I'll also be sticking around after the session if you have any additional questions or anything specific you want to talk one-on-one about, okay? So with that, let's go ahead and get started. Quick disclaimer, I'm always forced to show this. But let's start off with the bucket use cases for NSX. So the three main use cases we have are automation, security, and application continuity. And when we talk about multi-site, we're really talking about application continuity. And under this, you have a number of bucket use cases, smaller use cases, I could say sub-use cases. They're like disaster recovery, workload mobility, multi-site security, resource pooling. And we'll get into these in more detail. So again, I just want to mention here, there's a part two to this session right after this. And I also did a disaster recovery solutions session on Monday. So definitely, check those out. You'll have access to the recordings. And for all of these use cases I mentioned, we have a lot of customers in production. Also for application continuity, using multi-site security. Okay, this thing isn't working too good here because of the setup. I like messing around with this technology, but it doesn't always work. So let's start off with the medieval days of multi-site, or what I like to call the medieval days, right? You have your site one, or data center one, and you have your site two, and you want to do some kind of workload mobility, obviously, that's the goal. So you start off with your site one, you have your servers, you have your networking gear, you have your physical security appliances, you may have other physical appliances like load balancers, you may have ACLs, DNS, other application IP dependencies, right? And you have these workloads, and you want some kind of mobility between these workloads, right? So there's a lot of challenges you face when you want to be able to move these workloads to the other site. You have things like, the application IP address might need to change. And if you want to try to keep that consistent, then you're basically, reconfiguring your physical network for L2, L3 connectivity requirements. And even if the network is there, what about the security policies, right? Now you have to manually recreate these security policies, figure out a solution for that. And if the IP address changes, not only do you have to recreate these security policies, now you have to update them, right? And there might be other physical device configuration you have to update, as I mentioned, like load balancers, firewalls, and so forth. And if you have stuff like ACLs, application IP dependencies, then you have other issues to be concerned about, right? So if you look at these traditional challenges, some of the traditional solutions have been things like, L2 over dark fiber, where you're spanning VLANs. Now you have to deal with spanning tree, loop avoidance issues. Or VPLS over MPLS backbone, which is complex, requires long lead times, or a hardware-based solution like OTV. Now you have to have the same hardware on both ends, right? And all of these solutions I mentioned, right? First of all, you're like recreating a physical network here to solve these challenges. And then all of these specific solutions are very network-focused. They're not really attacking all the problems you have, right? So, and they're also device-by-device configuration. So you hope when the time comes to move, everything just works. But if you made some mistake in the configs, then things can go wrong, and you've probably had things, I'm sure, go wrong, right? So these solutions, these traditional solutions, they tend to be expensive, complex, hardware-based. They're not really agile. They're operationally challenging. They only address the network. You're doing per-device configuration, and really they lack the flexibility and automation we really desire and want. And really what I'm trying to say here is they're not holistic solutions. They're only focused on the network and per device configuration, and they lack the automation and flexibility we really desire and we really want. So let's talk about now the multi-site revolution with NSX, right? So we talked about these traditional solutions and all the challenges you have with them, how they're not holistic solutions. So we kind of want to just kind of do away with all of that. And what we want is a software-based approach, something that provides decoupling from the physical hardware, ease of deployment, ease of use, better security with microsegmentation across sites, something where we can leverage our higher level security constructs like security tags, not just IP addresses, which provide no context, can change, and are hard to maintain. Flexibility in terms of deployment, high degree of automation, rapid deployment and recovery, if you're doing something like disaster recovery, let's say, extensive partner ecosystem, which I show you in part 2, where you can use F5, you can use Palo Alto for layer 7 type security, integration with other software-defined data center components. That's one of the best parts, right? You have the whole stack, SRM, vSphere hypervisor, vRealize suite, so on. So NSX provides all of that. So let's start off with a basic example. So here I have a multi-site solution, and here I'm just going to demonstrate a disaster recovery example. So I have my active application at site 1. There we go. It's a little better now. Active application at site 1. And I have my standby at site 2. I'm using some kind of disaster recovery orchestration tool. Could be SRM, RP for VM, Zerto. We're agnostic to that, but we provide the benefit. And there are some integrations we have, for example, with SRM. So here I deploy my universal networks. How am I doing that? I'll cover it in more detail. But basically, I have a primary NSX manager here, secondary NSX manager here. I create my universal objects here. They automatically get synced to my secondary site. Now I can deploy universal networks across vCenter domains, across sites. I can deploy my universal distributed logical router for my east-west routing, my universal distributed firewall, microsegmentation across sites. And typically customers who have multiple sites have multiple vCenters, right? And if you're using a solution like disaster recovery, it requires multiple vCenters. SRM, RP for VM, Zerto, all of these guys, they require multiple vCenters for that additional segmentation. Okay, so now I can deploy my universal networks. I can leverage higher level security constructs like security tags, which are automatically synced to my secondary site. Okay, so I can now, on top of that, deploy ESGs for my ingress egress out of my software-defined data center. Right, on these I can also run things like load balancer, NAT, edge firewall, so on. So now I have my active application and I'm forcing all the traffic there out to site 1 ESGs. How am I doing that? Routing protocols. I can run BGP, I can run OSPF. Here perhaps I'm running BGP and using BGP weight to influence the routes out to site 1 ESGs. Now when this application goes down or when this site 1 goes down, my orchestration tool brings up these VMs at site 2 and it'll use the site 2 ESGs. The security tags are there. They provide the consistent security for my applications. Consistent networking, consistent security. So slide 1, slide 1, and already you can see a lot of those traditional challenges I mentioned are solved there. You have consistent networking, you have consistent security, you have higher level security constructs with security tags, right? You have inherent automation. So now we're going to kind of keep going throughout this presentation, but this was kind of like a starter slide to kind of introduce you to what we have here, the benefits. Okay, so let's start with use cases, then we'll go into architecture and some additional stuff from there. Okay, so when we talk about use cases, first of all, with universal networks, we're going across vCenters, which can also be at the same site or they can be across multiple sites. For multi-site, again, perfect use case. So now we have logical networks, universal logical switch, universal distributed router, and universal distributed firewall going across sites, across vCenter domains. Now that enables a number of use cases for us. The first one being workload mobility, where now we can easily move workloads between vCenter domains and between sites. And why might you want to do this? For things like data center migration, or if you're doing upgrades or applying security patches, you may just want to be moving these workloads temporarily, right? Or disaster avoidance, right? So that's one very powerful use case. Another use case is resource pooling. You may have idle capacity sitting in a vCenter or within a site, right? Now you're spanning these logical networks, you have consistent security, you can easily take advantage of that idle capacity And basically, this is giving you better overall resource utilization. Okay? Another use case is using unified networking and security policy, right? So it enables a consistent security policy across your vCenter domains and across your sites. So you're no longer required to manually replicate these policies, like I showed you in some of the prior slides. So you also have ease of security automation. So you can make one API call to this primary NSX manager here, just one call, and you know you'll have consistent security across all your sites. So you can put this in your advanced security scripts or automation scripts, right? You have higher level security constructs, universal security tags, automatically synced to the secondary site. So here I have an example where I have a client making a REST API call to the primary NSX manager. These security policies get created and pushed down locally. They also get synced to the secondary NSX manager and get pushed down locally. So you end up with consistent security across sites. Pretty cool, but you can also just do this through the GUI, of course. You can go to the primary NSX manager, create a universal security policy, automatically get synced. The point I'm making here is you can also just call one API call, and if you're doing like heavy automation, DevOps, you can take advantage of that as well. Last use case, and probably one of the biggest, is disaster recovery. You have consistent networking, so no need to do any kind of mapping. How many of you guys are doing disaster recovery today? And do you do network mapping or anything, or do you extend L2? Yeah, so see a lot of yes. So you know some of the headaches involved with that, right? By the way, I didn't ask, how many people today actually have NSX deployed? Okay, about half the audience. Good, we're getting there. Every year it's like more and more. How many have multi-site deployed with NSX? A couple. So the rest of you, I'm sure, are here because you have some interest. So hopefully you'll get what you want from part 1 and part 2, and then next time I come back, I'll see a lot more hands here. But okay, good. So disaster recovery is a good, very good use case. Consistent networking, but not just that, but consistent security. So now if your site 1 goes down, your disaster recovery orchestration tool brings up these workloads at site 2. You don't have to do anything. The networking is there. The security is there. The workloads come up and everything's good to go, right? And additional to that, we have integration with SRM. So if you're using security, storage-based policy protection groups, it can actually do some automatic mapping because it sees the same universal network on both sides. So it can save you some more time. At the end of the day, what this is really doing is lowering your RTO recovery time objective, right? That's very key. That's why, combined with solutions like SRM, Zerto, RP for VM, fantastic solution. We have a lot of customers doing this. And again, if you want more details, I actually showed a demo on Monday with cross vCenter NSX in a multi-site environment using Zerto. Last year I showed SRM, so this year I switched it up and used someone else. But again, we're agnostic. Use whatever you have or whatever you want. Okay? So now we kind of understand some of the benefits. We know the use cases. Let's look at how some of this stuff works. Look at some of the architecture. Any questions so far? Okay? Feel free to ask along the way. I want to make sure we're kind of all on the same page as we progress because it gets more and more technical, okay? Especially when we get to part 2. So, let's cover some basic concepts. Yes?
Quick question on that first item there. We're not doing, or that you pulled it up there, we're not doing cross today. As we create the objects today, if we get to a point where we go with enterprise and do cross vCenter NSX, is there a way to make those objects become universal?
No, so they have to be created universal. There's no when you create a universal object, there's a lot of things done in the back end. That's why, there's a lot of technical aspects to that. But in the part 2, I do explain how you go from a local environment where, let's say you have 2 local sites using local NSX, separate controllers, how you go from that to universal. Okay. So let's start off with some basic concepts. We have these universal objects. So these are now objects that are spanning multiple vCenter domains, right? Local objects are, within one vCenter domain. We have primary NSX manager. So we have these roles we created for NSX manager. Before it was always standalone mode. That was always the default. In 6.2, we introduced this concept of primary, secondary. So you have one primary NSX manager where you create your universal objects. you have a secondary NSX manager, and you can have up to 7 of these secondary NSX managers, 1 primary NSX managers, total for 8 NSX managers. Secondary NSX managers, the primary syncs the universal configuration to, okay? But the universal objects are only created from the primary NSX manager. So you can see here I have an example. We have multiple roles now, but primary and secondary. So this first line is a vCenter, and you can see this NSX manager that's linked to this vCenter. I've promoted it to primary. Then I go on this NSX manager and I give it the credentials of the second NSX manager sitting in site 2. The second NSX manager then gets promoted to secondary. Now I can create a universal object on this primary, and it gets synced to my secondary automatically. Okay, that's how that works. Now, when I make that first NSX manager primary, a universal synchronization service starts on it, and that syncs my universal object configuration to my secondary NSX managers. Right? So controller cluster, we still have 3 controllers. They manage both the local and universal objects across both the sites. Now, same as before, each NSX manager maintains a connection to each of the controllers, and you can see the status in the status column here. Now, I mentioned there's only 3 controllers, but you see 6 rows down here, 6 rows under the controller nodes. So the reason for that is because you have 2 NSX managers, and what this is really showing is the status connectivity of each of the NSX managers to each of the controllers. Since there's 2 NSX managers, 3 controllers, it gives you 6 rows, right? But if you look at the IP addresses, these bottom 3 IP addresses are the same as these top 3. So the bottom 3 are the primary, and you can tell that by the green boxes in the peers column. The top is the secondary. Okay? And just as before, each manager connects to each of the controllers to push the logical networking configuration. Also, a periodic keep alive is done to monitor the state of the controller cluster and to measure disk latency alerts. So very similar to before, nothing has changed here, but now you have this universal concept and primary and secondary NSX manager. Okay, now universal transport zone. You're familiar with the local transport zone. That's the boundaries of your local logical switches. Universal transport zone is the boundary of your universal networks. Okay, so same concept. A lot of these, the concept is the same, but now you're going into like a universal kind of context. So universal logical switch is the same thing as a logical switch, but now this can span multiple vCenter boundaries. So what defines if a logical switch is local or universal depends on what transport zone it's deployed in. If it's deployed in local transport zone, it's a local logical switch. If it's deployed in universal transport zone, it's a universal logical switch. If you have UDLR, Universal Distributed Logical Router, same thing as DLR, but now spanning multiple vCenter domains. And at deployment time, you select if it's a local DLR or a universal DLR. Okay? So now that and you actually here, I guess I show I didn't realize I included this, but I do show a GUI here where you can see it's a universal distributed router deployed, and it's deployed on the primary NSX manager. Okay? So now that we understand the basic concepts, we understand the use cases, we understand the advantages, let's talk about how some of this architecture works. We understand some of this terminology now, right? So this should be a little bit more straightforward. So I have my vCenters, my separate vCenters, I have my separate NSX managers. These can be all in one site, these can be across multiple sites. Okay? So by default, all of these are standalone mode. This NSX manager, this, and this guy, they're all standalone mode. First thing I do is come to one of the NSX managers, I promote it to primary. Okay? Next thing I do, I give this guy the credentials of the other NSX managers, and these guys then become secondary. Okay? Now from the primary NSX manager, when I made this guy primary, what happened was a universal synchronization service started on it. And this is what I mentioned earlier in the definitions. It syncs that universal object configuration to these other secondary NSX managers. So that's going to become key here. From the primary now, I can deploy my universal controller cluster into the inventory of the vCenter that the primary NSX manager is linked to. And then this universal synchronization service will sync that universal control cluster config to the secondary NSX managers, which then know how to connect to that universal controller cluster, right? Now, each of these NSX managers has a message, yes?
So when you first create that NSX manager, and if you already have a controller cluster, and you promote it to a primary, does his controller, that existing controller cluster become a universal controller cluster, or do you have to start over?
Yeah, so... Yeah.
What's the process? You have to get rid of those controllers?
Yeah. Yeah. So that's a bigger discussion. That's why I put that in part 2. Are you going to be here? Yeah. Because if I get into that right now, the session's going to be done. But the concept is, what was the first question? The first question was just yeah, if they're there, okay. So it's an in-place upgrade. Those will become universal. You don't have to delete them. But to answer the bigger question, let's wait till part 2. Yeah, that's why we have 2 parts, because there's just, and even 2 sessions is not enough. I do really struggle to figure out how to fit all this in 2 parts. So now what happens is each of these NSX managers has a message bus connection to the ESXi hosts, right? So that universal control cluster config is now pushed down from the NSX managers to each of the hosts, and now the hosts all know how to connect to the controller cluster for that control plane connectivity. Okay, so that's how this stuff works. So now when I create a universal object on the primary NSX manager, it automatically gets synced to the secondary NSX managers. So let's look at how this works. So again, I have 3 NSX managers, could be at the same site, could be at different sites. I have 1 primary, and I have the other ones are secondary. I already have my universal controller cluster. I deploy my universal logical switch on the primary. That information gets stored in the local NSX manager database. It also gets pushed to the universal controller cluster, the VNI information. Okay? Now, also, it gets synced to the secondary NSX managers, which store it locally in their database as well. Okay? Now, if I'm creating local logical switches, I can create those still on any of the NSX managers. So let's say this guy here, because I'm closest to it, and I can just go like this. So I can create a logical switch here. That information will get stored in the NSX manager database here locally, and also pushed to the universal control cluster. So you can see this universal control cluster as kind of a shared object for both universal and local objects across all my vCenter domains. Now, you'll see I didn't mention anything about security in any of that. And what's nice about this is the architecture is such that you can actually apply universal security without doing any networking. It's a very powerful use case. I mentioned it's one of the use cases, multi-site security. So let's take a look at the security architecture. So first, we have to understand some concepts, universal distributed firewall. Again, same thing as distributed firewall, but now you're going across vCenter boundaries. Think vMotion, across multiple vCenter domains. You still have that policy in place. Okay? Universal firewall rules, same thing as local, but now these are going to be synced across all my vCenter domains. So I have consistent policies when those workloads move. So here I have a universal distributed firewall section in my distributed firewall. In this universal distributed firewall section is where I create my universal distributed firewall policies. Okay? So now that we understand some of those concepts, let's look at how this architecture works. So again, I have my respective vCenters and NSX managers, primary NSX managers, secondaries on the other sites. Okay? I have my managed bus connection from each of my NSX managers to each of the respective hosts. Now, I create my universal distributed firewall rule on my primary NSX manager. It gets stored locally in the primary NSX manager database. It gets pushed down to the ESXi host via the message bus. At the same time, it gets synced to the other NSX managers, which get stored locally within their databases, and then also pushed down via the message bus to their respective ESXi hosts. So now I have consistent networking across all my vCenter domains. And you can see here there's no controller cluster. Controllers are not used in the security architecture. Okay? Now, most of our customers deploy both together, but we do have customers leveraging this for the powerful multi-site security capabilities. Right? I mean, this is, I can't stress enough like how important this is. You have central management of your security policies. You have consistency, across all of your sites. And those policies move with the workloads when you vMotion across vCenter domains, across sites. You name someone else who can do that. That's very, very cool stuff. So let's talk a little bit about the networking. So here I have a setup. This is what I call multi-site, multi-vCenter, active-passive site egress. So let me walk through this. So here I have a primary NSX manager in a vCenter, a secondary NSX manager in a vCenter here. I have ESGs deployed across both of my sites for my north-south ingress-egress. I have my universal distributed logical router, and I have a universal control VM, which is the control plane for my universal distributed logical router. And I have my universal networks and my universal distributed firewall. Now, this universal control VM peers with the ESGs across both sites. It learns the best forwarding information. Now, I'm controlling that through routing metric, and I'm saying the ESGs at site 1 have a higher metric, such as maybe BGP weight, if I'm using BGP. So the control VM gets that routing information, passes it to the universal controller cluster, and that controller cluster is responsible for distributing that forwarding information to the host. Now all the hosts know the best forwarding path is out the site 1 ESGs, and workloads across both sites use the site 1 ESGs. Now if connectivity is lost here, universal controller cluster will get the new routes. We'll say, okay, the new routes are out. The site 1, 2 ESGs, obviously, it'll pass that to the universal controller cluster. That information will be forwarded to the hosts. Now the host will use the site 2 ESGs. Okay? So this is one model here. Another model, and again, there's a lot of flexibility in terms of deployments. I kind of chose two models I kind of see often that I thought would be good to demonstrate here. But it's all in software. That's the nice thing about NSX. With multi-site, you have a lot of options. There's a multi-site design guide I wrote. Go check it out. You'll see all the capabilities. I'm in the process of updating that for new features we've added in 6.3. Here's another model, multi-site, multi-vCenter, active-active site egress. Now you'll see this is very similar to the first one I showed you. A few key differences. First of all, we have something called local egress enabled. I'll explain that as I walk through this flow. Second, we have a control VM, universal control VM at each site. When you deploy local egress in this model with network stretching across, it automatically deploys a universal control VM at each site. So each of these universal control VM is peering with their own ESGs at their local sites. So let's see what happens here. Again, universal control VM is peering with ESGs at site 1. It gets the best forwarding information. It passes that to the universal controller cluster. However, you'll see it passes it to the universal controller cluster with something called a local ID. Okay? So what is this local ID? This is a unique 32-bit identifier. By default, it's that of the UUID of the NSX manager, the local NSX manager. And these hosts have that same UUID by default. Okay? So this is passed with the routing information to the control cluster. And we'll see later on how this is used as a filtering mechanism when these routes are distributed. So at site 2, I have the same thing going on. This universal control VM is peering with the ESGs. The best forwarding information is pushed to the control cluster with its local ID, that's of its local NSX manager. And these hosts have that local ID as well, the same local ID. So now the universal control cluster has routes for both of these sites, and it distributes these routes to the hosts that have a matching local ID for both site 1 and site 2. So by doing this, we're able to do site local egress or north-south routing. Okay? Now, I will say between the first model I showed you and this model, the first model is actually more common. And there's several reasons for that. First of all, people deploying this type of solution, this type of advanced solution, they pretty much have a good DCI, high bandwidth, low latency, pretty good resiliency. right? Second, most of the traffic within a data center is east-west. Only about, from what I've seen, 15% or less is north-south, right? So although you can deploy an active-active model, it introduces additional complexity when it's not really needed for most customers, right? Because now you might have asymmetric traffic flows where traffic can go out one data center and come in another data center, right? Now, that might be fine, and we do have customers deployed like that in small campus environments. But if you don't want inefficient traffic flows, or if you have stateful services in between where things may break, then you have to handle that ingress traffic. So, and we do have ways of handling that. I covered that in part 2, /32, host route injection, GSLB, so on. But the point here is it introduces additional complexity. And for most customers, it's not really needed, right? So that's why the first model is typically more common. Okay? So what I want to do now is talk about some of the additional capabilities we've added in NSX 6.3. So here I'm going to talk about some additional resiliency we added for the control plane. Now, before I do that, I want to mention the controller cluster is already inherently resilient. Why? Because you're natively leveraging vSphere HA. Also, it's a cluster. By definition, a cluster is resilient, right? That's what clusters do. That's why clusters are there, for scale and resiliency. So you can lose one node, and the controller cluster keeps functioning. The control plane keeps functioning. In fact, because NSX has complete separation of control plane and data plane, you can lose the entire controller cluster, and your program data plane keeps forwarding. Okay? Now, before I get into this, I should mention, what the controller cluster does, just as a refresher so everyone can follow along. So controller cluster knows the state of the entire network. So as workloads come up, this controller cluster says, is it notified, hey, this VM just came up, it's on this logical switch behind this host. Now, this logical switch is just a VXLAN. It is a termination point. That termination point is called VXLAN termination endpoint, VTAP. Every host has a VTAP, right? So when this workload comes up, this controller cluster is notified, hey, this VM sits on this logical switch on this host behind this VTAP. So now when this VM on the left wants to communicate with this VM on the right, it gets that the host 1 gets that information from the controllers, the communication works fine. Now, even if the second VM moved to host 2, the controller cluster will be notified, that information will be communicated to the host, communication will work fine. Okay? However, what happens if you do have that rare instance where you do lose the entire controller cluster? Now, the data plane's already programmed. It will continue to forward, so no issues there. But what if the second VM moves to this host 2 on site 2, let's say? This is where you would have a data plane disruption. Why? Because now this host 2 wasn't a member of this logical switch before, but now it is. But it can't communicate that to the controller cluster, which can't distribute it to the other hosts. So this is where you'd have that data plane disruption, and this is where that enhancement of CDO mode comes in, where we brought this feature to cover this niche corner case. So now you can enable CDO mode on the transport zone. Okay? And now when you do that, what happens in the back end is a CDO logical switch gets created, and all members of that transport zone join that CDO logical switch. And a global VTAP list gets created. This global VTAP list basically has all the VTAPs of all the hosts. Okay, so keep that in mind as I go through this next flow. And I covered some of these scenarios more in part 2 as well, but I wanted to introduce it here as an enhancement. So now I have CDO enabled, and let's say my controller cluster goes down, my VM moves to host 2, site 2. Communication continues to work. How is this possible? Well, we're not using the controller cluster at this point. CDO mode is enabled, so it uses that global VTAP list, and the bump traffic is broadcast to all the VTAPs to allow the communication to continue working even if the controller cluster is down. It's a very cool feature, and specifically, more important when we look at multi-site and disaster recovery. Okay? Yes? Sorry, I could not hear you. Yeah. Yeah, so I cover these scenarios in part 2 where I talk about like NSX component recovery and that. But in this case with CDO mode, you actually don't need the controller cluster at Site 2. And we don't do that. It actually prevents some other issues like split brain you can have and some other complications. So it's a good architecture with the controllers at Site 1. We have CDO mode to allow for things to control plane to continue working even if the controller cluster is down. But I do have a recovery process I cover in part 2 as well. Yes?
What's the overhead penalty of enabling CDO mode that made it so that it's just not by default?
Yeah, so good question. I mean, there is some resources it consumes, but it's not significant is what I'm saying. What happens is we wanted to give, this is the first release of CDO mode, we wanted to give the option to allow customers to say, I want to use this. There's some additional technical details. I wrote a CDO white paper. You can take a look at that, but I'll answer your question in short here. But I go into details in that white paper. You can find it online. There's a link to it on the network virtualization blog. I wrote a blog there on this CDO mode. But basically, you can only enable CDO mode. Let's say you have two transport zones that are sharing a VDS. In that case, you can only enable CDO mode on one of the transport zones. Okay? So there's some additional details there, and we wanted to give the option based on customer's design that, hey, enable this, where you need it and when you want it. And when you're broadcasting this traffic, again, it's not as efficient as the controller cluster because you're broadcasting it everywhere, where controller cluster is telling you exactly where to send that traffic. So it is not as efficient mode, but it's a mode that keeps things running, until you get your controller cluster back up. So we wanted to give that option there to customers.
It's only broadcasting that traffic when the controllers are all offline?
Exactly, when you lose entire control plane connectivity. When there's no more control plane connectivity to the host that uses CDO mode.
Real quick question. You showed the example where VM moves to a host in Site 2, but would you have the same problem if VM moved to a different host in Site 1 where it would move and still...
Yeah, you could still use this locally. It's like I said, it becomes more important when you have multi-site, right? Because you have control cluster on one side, it becomes a little bit more important. But you can use it also locally. Yes. Okay. So now I want to cover some of the cool enhancements we have for security that we added in NSX 6.3. So before I do that, just want to cover a quick primer, like the benefits of universal distributed firewall. Here I have universal networks. I have my workloads at Site 1. I have universal distributed firewall. I have primary NSX manager here, secondary NSX manager here, right? I have my web VM talking to my database VM. I want to prevent this communication, let's say. I want my web to go through my app tier to talk to my database. So I create a universal distributed firewall policy. This is consistent across both sites. So let's say my web VM moves to Site 2. That policy remains consistent and things work as expected where they're not allowed to communicate. Even if the entire application is now moved, again, consistency. So this is the real benefit. Policies move with the workloads. You have consistent networking. Very powerful capability. Okay. Now, some of you may know that prior to NSX 6.3, we only had the ability to use universal IP sets, MAC sets, universal security groups, services, and service groups with universal policies. Now, with 6.3, we can use universal security tag and also VM name. So we can actually create universal security groups with matching criteria of universal security tag and VM name. The important thing to mention here is this is only for active standby deployments. I'll explain that a little bit more later on. But basically, if you have security policies between the tiers, that entire application has to be either at Site 1 or Site 2. Okay? So we have some general enhancements. Multiple universal distributed firewall sections. Apply 2 can now use universal security groups. I'll cover these in more detail in the next slides. And we also have some enhancements that are specific to active standby only. So the general enhancements are you can apply to active standby or active-active. The standby use cases obviously are only for active standby scenarios, these specific enhancements here. Okay? So under the standby enhancements, we have universal security tags now. We have universal security groups you can create with new matching criteria of universal security tags and VM name. So prior to 6.3, we'll start with universal sections. You could only have one universal section. Now you can have multiple universal sections. So a benefit of this is when you update a universal section, only those specific rules in that section get synced to the NSX manager, not everything, right? And you can also organize your rules more easily per tenant. So here you can see I'm creating a universal section. Okay. Now universal sections are always above local sections, which makes sense because if you have a global security admin, he'll create these security policies, universal security policies. Local admins can still create local security policies, but they can't override the universal. So if you actually try to create a section above a universal section, it'll default to universal because you can't create local above universal. Okay? Apply to. So prior to NSX 6.3, apply to could only use universal logical switch. So what was the consequence of this? There was a couple consequences. First of all, the most granular you could apply security policies was at a universal logical switch level, meaning all VMs on that universal logical switch would get security policies applied, even if some of the VMs didn't need that policy. Second consequence was, as I mentioned, we have customers using this for the powerful multi-site use case. So they're just leveraging cross vCenter NSX for multi-site security. They couldn't really leverage apply to because it only worked with universal logical switch and they don't have universal networks deployed. So now we allow it with universal security groups with this new matching criteria of VM name and universal security tag. So here you can see I'm using apply to and I'm selecting a universal security group which has this new matching criteria of universal security tag or VM name. So this allows you to apply these policies at a very granular level to the VM, and also people leveraging this just for multi-site security can take benefit of this now. Okay, so here you can see I have a policy, and in the apply to field, I have this universal security group with this new matching criteria. Okay. Additional enhancements we have. Now we have universal security groups using these security tags and VM name, right? So you can see here, I'm creating a universal security group. Okay, just as before, you have that option of marking it for universal. And if you just leave it as is, you'll get the options that you're familiar with, right? IP sets, MAC sets, and security group. Okay. However, now you'll see there's another checkbox here that says use for active standby. And if you select that, you'll get additional options where you can now dynamically find VMs based on VM name. You can also use security tags. You can see security tag in here, right? So let's walk through an example here, and I'll use security tag. So first thing I do when I'm leveraging this capability, and this is probably one of my favorite features in NSX 6.3, is on the primary site, I set unique selection criteria. So what is this? This is basically a unique identifier. And why do I need this unique identifier? Well, when you create a universal security tag, it's automatically synced to the secondary NSX manager. Syncing it is one thing, so it's there. But what about when the VMs actually move there or are recovered there? How does the NSX manager know which tags go to which VM? You need some unique identifier, right? And that's what this is. So we offer a couple different options here. We offer VM instance UUID, virtual machine BIOS UUID, and virtual machine name. Or you can choose a combination of them. Now, typically, virtual machine instance UUID is sufficient enough. It's not guaranteed to be unique across vCenters, but it's very rare that there's overlap. For instance, when SRM replicates these VMs, it maintains, or when vSphere replication actually is replicating these VMs, it actually maintains that instance UUID, right? So when your workloads are brought up there, you can be assured the correct tags will be applied based on that instance ID. However, you can use, the other options as well. You can use VM name. That's what I'm using here. If you're using VM name, you want to make sure your VMs have unique names, obviously, right? Because you're using that as a unique identifier. So first thing I do is I go to the primary NSX manager, I go to installation tab, I select my primary NSX manager, and I set a unique selection criteria. Here I select VM name. Next, I create that universal security tag, which will automatically get synced to my secondary NSX manager. Okay? Now, on the primary NSX manager, I apply that tag to the respective VMs. Okay? Now, when those VMs are moved to site 2 or recovered at site 2, the correct tags are applied to the correct VMs based on that unique selection criteria. And then you're assured the correct security policies are applied based on that tag, right? So pretty cool stuff. Definitely one of my favorite features. And what I want to do at this point is I want to show a demo of some of this capability. Yes? Yeah, good question. I go and do more of that in part 2, but the limitation is just, as a quick nutshell answer, the limitation is the NSX manager at site 1 and vice versa doesn't have visibility into the other vCenter. So when that VM moves, although it has the right tag applied on the other vCenter, NSX manager 1 can't see that VM because it's in the other guy's inventory. Okay? So let's look at a demo here. So I have my multi-site environment here. I have San Francisco and I have Phoenix. And I'm not using enhanced link mode, you can see here. So I go to San Francisco site. I go to my web VM. You can see it's on this subnet ending in 201.1. It's on the Universal Web Tenant 1 logical switch. I go to my app VM. It's ending in 202.1, a different subnet. It's on the Universal App logical switch. I go to my database VM, 3-tier application here. It's 203, ending in 203.1. It's on the Universal Database logical switch. Okay? So I'm going to go to my web VM here. I'm just going to console in. And before we do anything, you can see it's the same VM, the web VM. Before we do anything, I'm just pinging 202.1. So you can see the communication is good to the app VM. And 203.1 the database VM. Communication is good here. Okay? So now what I'm going to do is I'm going to go to my NSX Manager, Networking and Security tab here. And I'm going to go to Installation. I'll go to my primary NSX Manager here, and I'll set that unique selection criteria I mentioned. And again, I'm just going to use virtual machine name here. I've already set it up, you can see. Okay, so now I've set that up. Next step is go to my NSX Manager and create my universal security tags. So I go to this NSX Manager, and I go to security tags. And now when I go to create a security tag, you'll see a new option that says mark this for object for universal synchronization, right? And this is basically creating that universal security tag. So I create one for web. I'm going to go ahead and do the same thing for my other tiers. My app, and also my database here. Okay, so once that's done, I basically have to now put this tag on my respective VMs, right? That's what I'm doing here. I'm going to the web, assigning the security tag to the web VM. I do the same thing for my app, and you can see the numbers are increasing in VM count. It's showing you how many VMs have this tag. I do the same thing for my app. In database, I'm going to do the same thing. In the database, I'm going to put 2 VMs just to make a point later on in the demo. I'm going to put database 1 and database 1.2, which are both on the same universal logical switch. Okay, so now you can see the numbers there. I go to my grouping objects, and just for demonstration, I'll just show one just to save time. I'll show creating a security group for my web tier, but I did this for the app and database too. I mark it for universal sync. I select the second option here, which is key, which now allows me to put VMs into the security group based on that security tag. So I say put all VMs in this group that have this web security tag that I just applied, right? And again, I did this for app and database. I cut it out here to save time. So they're all done. Web, app, database. Okay, next thing I do is I go to my distributed firewall. I go to my universal section. Here I've created some of the universal sections. I go to tenant 1. I start creating that policy. And within this policy is communication from web to database. I want to block that, right? I want it to go through the app tier to talk to the database. So for source, I select that web security group based on that security tag. Destination, I select the database security group based on that security tag. And I'm just going to change this to block. Now, the same security group I'm using here in source and destination, I'm also going to use in this apply to field I mentioned. So all this policy will only get applied to whatever VMs I select here. I select the web VM. And then I create another policy from database to web, and I just, to save time, I just did that here, and I commit this policy, and I apply that to only the database group. Okay, so now if I go back to my web VM, and I try to ping my app VM, it should work as expected, but if I try to go to the database, it should be blocked based on that policy using security tags. Now, this is cool, but it's not that big of a deal right now. The big deal comes when these workloads are actually moved or migrated to Site 2 or recovered to Site 2. So let's do that. And what I did here is I'm basically doing a cold migration use case. So I go and shut down all of these VMs here. I take the VMDKs, I attach them to other VMs, and I bring them up at Site 2. So here I shut down the web VM, and I cut some of this out. I just shut down the other VMs too. I bring the VMs up on Site 2, and the VMDKs I attach to these VMs. So now their VMs are going to come up here. It's basically I'm doing cold migration. Okay, but the VM names you can see are the same. So now I brought them all up. Security tags will be applied based on that VM name. Go to my networking security. I go to my NSX manager. This is my secondary NSX manager. You can see all the universal tags are there. They were synced. And if you look at the count and I click on it, you can see they're applied to the correct VMs. It's applied to the web. If I click on the app, you can see it's applied to the app VM. Okay? So they all got applied. I only moved one database VM in this case, so it's applied to the database. The other one I left at Site 1 to show you something later. Okay? So security groups, again, they all got synced. Universal distributed firewall rule, they all got synced. Don't have to do anything. Right? That's the benefit. You do it on once, it's there on all your other sites. Now, if I try to ping the app VM, as expected, it should work. Again, the database should be blocked, proving, hey, I just did this cold migration or recovery, and these policies based on tags are working. Right? Pretty cool. But now, if I try to ping the second database, this first database is blocked as expected. The other database I left at Site 1. I'm going to try to ping it. What do you guys think? Will it work? Yeah, it'll work, right? Because remember, I said the app has to be on Site 1, Site 2. It can't see that VM sitting at Site 1, even though that tag is applied. So that's what I wanted to show you here, just demonstrate, that scenario. Okay, so pretty cool stuff here. And in summary, what I want to say is really what we're achieving here with Cross vCenter NSX. What this is providing you is basically a platform for building multi-site solutions. So you start with your vCenter, your NSX manager, right? You have a foundational solution here that provides you inherent capabilities. But now you have a platform on top of that, as I'll show you in part 2. You can deploy Palo Alto for application level security. You can deploy F5 to do something like GSLB and active-active, handle that ingress traffic. You can deploy SRM for disaster recovery plans, vSphere replication to replicate your VM. So the point here is this is an entire ecosystem, an entire platform for your multi-site solutions. And that's all I have for you. Please make sure to fill out the survey. I'm hoping this was very beneficial for you. And hopefully some of you will be sticking around for part 2. Feel free to stay in touch with me as well. Now I'll open it up for questions. Any questions, feel free to ask, or you can also come up after and talk. Yes?
Why not always select all 3 selection criteria?
You could, but it depends on, it depends on your tools you're using. For example, SRM replicates or keeps the instance UID consistent. There's not really a need to use anything else. Then you're doing additional matching on additional stuff. You don't really need that. Yeah, I mean, you could use multiple, but ID is sufficient, right? Like you could use VM name. VM name, you can see the instance UID right away. Like instance UID, you have to go into the managed object browser to use. But it really depends on your tools and what you're using and your environment. That's why we gave you the option. For example, SRM maintains it. Zerto doesn't. So in the Zerto demo I showed using VM name, right? The intent I believe there is also that they will allow you soon, I believe, to maintain the instance UID. But it really depends on your environment, and if there's not a need to try to do this additional matching, which will be some additional work, you can just use what's sufficient. Now, to answer your question a little bit deeper, I was curious, like what would happen if there was overlap, right? It's very rare, I've never run into it, but I had to actually go into the second vCenter and manually change an instance UID to make sure there was overlap, just to make this happen, to see what would happen. And when I tried to vMotion or when I tried to do this, it basically vCenter told me in one of the stages there that basically this ID is being used. And also when you're doing testing, when you're testing, like say you're doing this for disaster recovery, which is the primary use case for the tags. When you're doing testing, you can test to see are your security policies actually working, right? Yeah.
So you had non-link mode there. So it's the same, you have just link mode?
Oh, yeah. So I showed this without enhanced link mode, just as, I did this, so I recorded it. So, let me just show it this way. It's another way of showing something. I always show enhanced link mode. So I said, I just like to switch it up once in a while, just to show it's possible. So in this case, if you don't have enhanced link mode, what I showed you there, like if you're doing disaster recovery, perfectly fine. You don't have the same single sign-on there, right? But you're still able to do it. It still works. Now, if I used enhanced link mode, you're sharing a single sign-on, things will work. You can do vMotion through the GUI. Here I couldn't, right? So I did that cold migration to show you something else. So good. I mean, good you picked up on that. That's. Yeah. So there's some capabilities we've added in, or we're looking at. So in NSXV, there's not there. I mean, this is usually a private connection, so not much of an issue. Okay. Yeah, in that case, you would be basically relying on your underlying infrastructure for this solution. Yeah. So connect with me after, and I'd like to discuss that a little bit more with you to see. Yes.
What in a normal operation when the controller cluster is there? Is there one traffic get forwarded?
Well, so you have to remember. So we're talking at a lower layer here. So that host, it was never part of that logical switch, right? So the host that I'm moving to now in part 2, I'll show you some different scenarios where it would work and it wouldn't work. But the scenario I showed you was basically that host, the control cluster went down. That host was never a member of that logical switch. So it might have a VTEP, but it never was a member of that logical switch. So its VTEP is not in the VTEP table for that logical switch. That VTEP table is distributed by the controller cluster, right? So the controller cluster is now down. Now when it's down, that VM moves to that host. Now that host becomes a member of this logical switch. So now its VTEP needs to be added to that VTEP table for that logical switch. But it can't be communicated to the other hosts. So the other hosts have no idea that this new guy has joined this logical switch, right? That's what the controllers does. It distributes that information, but it's down. So that's why I'm using the global VTEP list, which is just basically broadcasting it. It's not as efficient, but at least it keeps things working, right? Well, it's only in the scenario where the controller cluster goes down, as gentleman earlier mentioned. You can use it locally, or you could do it in multi-site scenarios.
What's the latency required? Is there a latency limitation?
100 between sites, 100, yeah, I covered that in part 2, but it's 150 milliseconds less, and that's for enhanced vMotion, but it's also in line with our NSX control plane.
Save it on my tough questions.
Okay, well, I'm worried now about part 2.
Are you going to cover MTU size challenges between sites and part 2?
I mentioned like what the requirements are, but I don't go into detail. If you have some specific questions, I can answer them now, or you can wait.
I guess a future use case would be VMware Cloud and AWS.
Yeah, yeah. So these are things that are being worked on, right? And that use case is there. So right now we have IPsec up to, Amazon, AWS, and there's certain things you can do. The disaster recovery thing is something, we're looking on, and those challenges are there, and we're going to see how to do that. Now, we have cloud environments I covered in part 2, like IBM Cloud, for example, where we have customers doing direct connect to IBM Cloud and doing this. They offer different connectivity options like direct connect, L2 VPN, IPsec VPN. Do we have to clear out? Or? Oh, okay.
So this question was really good. I hadn't thought about that. Because we're interested in very certain things, being able to do our ER on Azure or AWS.
Yeah.
How are we going to ensure that?
Yeah.
Specifically, DX doesn't support a 1600 site.
Well, you guys are digging in a little deep, which is good because you're thinking about some of these challenges. So we're looking at that. There's different options there, and we're working also with Amazon, to kind of see. But, think about like the DR use case. Do you really need, for full site DR, do you really need MTU? Because you're not actually doing any traffic, right? So you can actually do DR and not have the 1600 MTU, because as long as you're not trying to do some kind of partial application failure or something, right? So you can configure across vCenter and NSX, not have the MTU, but still have the DR use case, right? It's only when you're actually sending traffic across, like workload mobility, partial application failure, where you need that MTU. But with DR, you're just basically bringing up on this side. You're not doing any traffic. All you're using cross vCenter and NSX for in that case is consistent networking and security, which it gets you. Exactly, site. So if you guys, any other questions?
Can you do active, passive with 2 different workloads and 2 different sites? So
Yeah,
the site is active.
cover that in part 2. Yeah. Hey, Ken. So Ken from F5 Networks is here. He's going to present with me in part 2. So he has a lot of good stuff. And he helped me a lot with, the F5 integration with this, multi-site. Yeah, I don't really get into that. There's so much content. Like I said, I had a tough time, even in part 2. You can ask Kent, like we were rehearsing this, and I was like, man, Kent, what do I take out? What do I take out? It's like, I don't want to take anything out. All this stuff is good, but, it's really tough to get everything in. But yeah, we're continually improving. You can see this universal security tag. You're going to see some of the cool stuff we did. Now, Panorama, there's a new model. You'll see where they can do active standby across sites and, link to multiple. So you're going to see some of that cool stuff. Okay. Yeah. In this deck, there's a hidden slide in the back. I assume you guys will get the deck, but let me see if I can just bring it up. You can take a picture of it. Oh, yeah. That is going to be post VMworld. Yeah, I'm working on it. Hopefully, it will be this year's the goal. So here you can take a picture of this. There's a lot of content out there. I wrote all of these papers there, all these videos, all these blogs, so. Oh man, well, so before you go to the multi-site design guide, I would read the regular design guide, because that gives you an understanding of NSX. Once you get past the regular design guide, then now you can look at the multi-site design guide, which goes a layer above into multi-site, right? And then these other ones are like disaster recovery. These are all use cases or particular things. So I'd go from design guide to multi-site design guide. And then a lot of the features in 6.3, although they aren't updated in the design guide yet, I've written about all of them in these blogs. So you could read the design guide and follow up with these blogs. And then if you want to see some demonstrations, look at the YouTubes. And hopefully what I'm planning to do, what I typically do is these demos, I'm going to update to the NSX YouTube channel too, post VMworld. So you'll be able to look at those as well. But network virtualization blog, I also have a personal blog. It's just my name.com, homerahmed.com. But I write a lot on the blogs because they're just so easy to update and post. Updating a document takes time, publishing it and all of that. So the blogs are constantly up to date. So for the latest, I would keep checking the blogs and the videos I post. Okay, any other questions? That's it? Okay, so definitely stick around for part 2 then, and I'll take any one-off questions there.